Hello, and thank you for your interest in our talk. My name is Alex Moorline, and I work for Physical Sciences Incorporated. The U.S. Navy asked our company to improve communications on board unmanned undersea vehicles, or UUVs. We have invented the Deployable UUV Communications System, or DUCS, which is a lightweight, deployable antenna mast. DUCS will dramatically increase communication range and reliability in elevated sea states. DUX is a TRL5 technology, and at the end of this Phase 2 effort, we are looking for development partners to help us transition the technology into fleet service. PSI is a small business based north of Boston in Andover, Massachusetts. For 50 years, PSI has developed innovative solutions for our customers. Our skilled, multidisciplinary staff allows us to solve complex problems and expand the capabilities of the DoD. We have successfully transitioned numerous products, and notably have won the second highest number of SBIR awards in history. For those of you interested in optical communications, batteries, sonar, or mine hunting, I invite you to view the other PSI Tech Talks hosted at the Navy Virtual Technology Marketplace site. UUVs are a critical part of U.S. naval capabilities. During mission execution, they need to report back their reconnaissance, including position, images, and other data. Space aboard UUVs is extremely limited, meaning that traditional antenna form factors will not allow the UUV to perform its full mission set. The challenge is designing antennas that are very compact but high performance. They also must not affect the UUV maneuverability and mission duration. The system needs to function in a wide range of sea states of up to 20-inch waves. These requirements steered the design toward a deployable mast that stows compactly when the vehicle is submerged, but deploys above wave action at the surface. The antennas need to cover bands for communications and position, navigation, and timing, or PNT. PSI's DUX system will provide the benefit of improved UUV communications to the Navy and across the DoD through several key improvements over existing fixed antennas. The deployable mast will raise the antennas up to 18 inches above the hull, compared to 7 to 12 inches for the current mast. The stowed height will be less than 3.5 inches, meaning it will fit within the Torpedo Tube Launch and Recovery, or TTL&R, safe cap, enhancing UUV mission sets. Several Navy and commercial organizations could benefit from this technology, including program offices concerned with unmanned missions and mine countermeasures. There are numerous UUV OEMs developing future platforms and improvements to existing vehicles for the U.S. Navy. PSI specializes in rapid prototype development, so we focused on iterative development and early testing of the system. We were able to perform initial ocean testing during the Phase 1 program and tested our integrated prototype on board a UUV during the Phase 2 base effort. Our testing demonstrated the benefits of the DUX system compared to the existing UUV antennas through simultaneous signal transmission. We were very fortunate to have the support of a UUV OEM that acted as our development partner during the Phase 1 and Phase 2 programs. While the deployer doesn't need to operate when submerged, it does need to go wherever the UUV travels, so we made sure to test the deployer to 600 meters equivalent depth in a hyperbaric chamber. We showed that the deployer retained full functionality once it returned to the surface and over multiple pressure cycles. During the Phase 2 program, we were able to prove functionality of the initial prototype in a relevant ocean environment, raising the technology readiness level to 5. DUX deployed reliably and achieved strong multiband communications and vehicle positioning. Future prototype development will focus on weight reduction by reducing component size and tighter packaging. We plan to integrate the system into a demonstration UUV and perform operational testing at sea. Throughout the Phase 2 program, we stayed on schedule and budget while meeting our program technical objectives outlined in our proposal. There is not an off-the-shelf solution for UUV communications at this time. UUV OEMs spend substantial development effort adapting existing antennas to withstand submergence. Ducks would provide OEMs with a platform-agnostic sensor package that could be plug-and-play. As UUV capabilities increase, the importance of their assigned missions will grow. They need to be capable of long-duration autonomous operation. Without a way to reliably report back with mission data, their capabilities are wasted. Ducks will allow UUV operators to close the capabilities gap that currently exists. Ducks represents a significant benefit to the Navy. PSI has a strong history of SBIR transition, and our strategy for Ducks builds off these prior successes. Our initial efforts would focus on technical development, including integration with the UUV and demonstrating performance during a simulated mission. The MUUV Program of Record supplier has been selected as of September 2022. We are tracking the timeline for spiral upgrades to the platform that would include Ducks. We continue to keep in touch with the program TPOCs for additional UUV development and demonstration opportunities. There are also ongoing development of larger UUVs, such as the LD UUV and Orca XL UUV. The keys to transition to the wider fleet include multi-band antenna performance, compact size, and low weight. Our planned development addresses each of these points. PSI already supplies UUV OEMs with battery systems, with a proven track record of reliability. Ducks provides a modular sensor package with applications for mine countermeasures, mapping, and reconnaissance missions. Outside of the Navy and DoD, Ducks could provide operational cost savings through autonomy and rapid execution of tasks. Potential customers include agencies tasked with ocean mapping, such as NOAA and Woods Hole Oceanographic Institute, as well as the oil and gas industry and ocean search and rescue. We are pursuing interest from the Program Office and MUUV OEM to continue development of Ducks. We will advance the initial prototype, focusing on weight and size reduction during future research. We have successfully produced prototypes that will survive use and abuse, and are looking for transition partners who can help us scale up the product and get it into the field. Thank you very much for your time today. Please reach out if the deployable UUV communication system addresses your needs. For business development, please contact Sean Torres at the email below. If you have any questions on the technical end, you can reach out to myself, Alex Moreline. Thank you, and I hope you have a great day.